20.3 EZ isomerism. Okay, so what if cis-trans isn't going to make it? Well, looking at this, it has a carbon-carbon double bond, but all the groups are different. There's no obvious cis or trans going on here. So this is where you use the EZ notation, the EZ notation. So looking at this molecule here, a bit more complicated. There's the carbon-carbon double bond. Now, to me, it looks like it's cis because there's this methyl group and that ethyl group, but it doesn't work like that. They have to be the same. This is where we use the EZ notation. And of course, E stands for entgegen, which means opposite, which is what you and I would call kind of trans before this. And Z, USA, man. No, it's Z zusammen, which means together, which means cis. Okay.
Nein, Mr. Thornley, so sagt man das nicht. Nicht so.
Man sagt nicht Z-US-Amen, man sagt zusammen.
Und man sagt entgegen.
That is good. Thank you. So looking at this, you have to apply the Kahn-Ingold-Prelog-Thornley, there's no Thornley, the Kahn-Ingold-Prelog rules. Looking at this carbon-carbon double bond, this has an atomic number of 1, and this has an atomic number of 6. This has low priority, this has high priority, higher atomic number. Assuming that this is bromine, this has an atomic number of 35, and this carbon, not the whole group, this carbon has an atomic number of 6. This has high priority, this has low priority. So grabbing my high priority balls here, you see that this is high and this is high, and that to me looks like the trans. We're not using trans for these strange ones. Trans is in fact entgegen, which is E. So this is E, then we've got 5 carbons, something to do with pent, something to do with ene. The double bond between the carbons is between the second and the third, so it's going to be pent-2-ene. And there's a bromine on 1, 2, 3. It's going to be 3 bromo. Okay, let's put it all together. E, 3 bromo, pent-2-ene. Of course, now we have the Z isomer. Give me a second here. So this is now the Z isomer. This is a high priority. That's got a higher atomic number than that. And this has high priority. This has a higher atomic number than that. So now to me this looks like cis. We're not calling it cis, are we? Cis is going to be Z, which is Z. Or Z. The world seems to have adopted that. Okay, let's look at the IUPAC definition. Woo! I understand how to do this, but this definition sends me to sleep. So I don't think we're going to worry about that. I can't believe they're going to ask you to recount it. All right, let's look at the first example. There's no way that that can be trans or that can be cis because there are 4 different groups, or in this case atoms, attached across the carbon-carbon double bond. So we're going to need to use the Kahn-Ingold-Prelog rules. Cis-trans ain't going to cut it because you need groups that are the same to do cis-trans. Looking at the left-hand side, atomic numbers, I've just drawn those in. And so since iodine has a higher atomic number than hydrogen, iodine has high priority. Looking at the right-hand side of the carbon-carbon double bond, fluorine has an atomic number of 9 and bromine of 35. So bromine has high priority. Now looking at those 2 high priorities, I would say that is trans. Now we're not using trans, are we? Trans has now become, in this case, E. Doing it alphabetical, bromo is ahead of fluoro, is ahead of iodo, gives me that name for the compound. If I was to swap them round on the right-hand side, the high priorities are now in what I would call the cis position, but we're not using cis. Cis is now Z. Fascinating. Okay, let's look at another example. Now this looks like it could be trans, but it isn't, because that's a methyl and a propyl group. No, they've got to be the same. So looking at the left-hand side of the carbon-carbon double bond, it's the 6th atomic number for carbon that you need. You've got to ignore all the other things that are attached. The carbon is directly attached. So that's the number that you need. That looks like a cis to me. Oh, no, hold on. Cis is Z. 6 carbons in the longest chain. Double bond between the carbons is ene, and it's on the 2nd and 3rd carbon, so that's 2. And a chlorine on the 2nd one. Okay, so there we are. So try to draw this one out. E, 3-fluoro, hex 3-ene. Now try to draw out E2-fluoro, pent 2-ene. And we're done.